Hi, everybody. In this video for the Programming Bootcamp, we'll see the template example that you may use as a guide and just get ideas from as well for your projects. So if I head over to the GitHub repo, which is here, you will see a folder called Project Template. And in there are three files, defs.py, printing.py, and tic-tac-toe.py. So this is a template of a tic-tac-toe game. So assuming that you have this on your computer, as I do, you can have these files here in Spider, for example. I'm using Spider, and you will see the tic-tac-toe file, the printing file, and the def file. So this is a little program. It's a game. It's a tic-tac-toe game. Your project is a more complicated game. It's a chess game, but the idea is similar and many of the concepts are somewhat similar. So let me first of all run this thing just so we see how it works. So here, if we run the file, welcome to tic-tac-toe, we get a board of 3 by 3. It's turn for player X, row 1 to 3. So player X says choose row 3 and say column also 3. So now we have the new board here. It's the turn for player O. O says, for example, 2 and 2. And it's turn for player X. So let's say that X does row 3 and column 1. And now it's a turn for O. Well, O is going to block X's move. So they will choose 3 and 2. And now it's a turn for player X. X is going to block O, so they will choose 1 and 2. And, well, what's O going to do? Geez, I don't know. I'm not such a good tic-tac-toe player, but let's say 2 and 1. So X is, well, X might be blocking this and will be a stalemate, but let's say that X does a fatal mistake and does 1 and 1. And then O goes for 2 and 3. Oh, player O wins. That's the end of the program. Okay, so your project might look something like this with a chess game. Okay, so this is not the computer playing against the player. It's player versus player, but it's maintaining the state of the board, saying what's allowed and what's not, etc. Just as you see as an example. For example, if I do 1 and 1. And say that player O is also trying to be in 1 and 1. We get that spot is taken again, and it's again player O's turn. Okay, so that type of error checking should also be done. But of course, some things are not done in this program. For example, if we take a turn for player X and we say 10 and 3, oops, the program's going to crash. Okay, so an extra layer that's not available in this example is seeing, well, why they crash? Because we had a list out of index out of range, right? So that type of thing is not done in this example. All right, but let's see now that we've seen how the program works, let's see the files. Oh, one thing I just also want to show you this running from command line. So we're in the repo folder. So this is my shell. And if I do ls project template, there's tic-tac-toe. So I can do Python project template tic-tac-toe, and it runs here as a standalone program, not in the IDE. Okay, it's a program interpreted by Python. Okay, so again, I can do 1 and 1, etc., and play a game. All right, Control-C, stop that. All right. Now let's just look at the source a bit. So before we look at the logic of the source, the important thing, the reason that you have this template is that you could see kind of how to structure the files, or that's one simple way to do that. So there's one main file, which is tic-tac-toe.py, and this is the actual program that you run. Okay, so when I hit play, I play on this file here in Spider when I run it, and that's what runs. Or if I'll do arrow up, it has the run file of this file. Okay, tic-tac-toe.py. Right, so that's the actual thing that we run. Now, this file has something that you haven't seen before, and your instructors will speak about this more. It has, it doesn't have any, it's not a script in the sense that it doesn't do commands, print this and print that. It just has function definitions. So here's a function init board. Here's a function is piece. Here's a function, this is a big function in terms of implementations called check victory. Okay. And here is a very important function. It's called main. Now, it is a common paradigm in Python. In some programming language, this is standard. And in Python, it's a common paradigm for a standalone program that runs to have some function called main. And this will be the first point of entry. This line, line 78, will be the first line that effectively executes beyond definitions of functions. To get this thing going, you also need to add a line someplace in the file. It says, if underscore underscore name underscore underscore equals main, then execute main. What Python basically does when it executes this file, not as an imported file, but actually executes it, it sets underscore 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 to main, and then it treats this as a main file to run. Okay, you can read about it. There's more and more various places on the web, etc. But this is a way to have this as the entry point, as the first function that's going to be run. All the other things are not really run. They're not. Now, just to make things a bit broader, I also included, I used two other files. So this is not just a single file program. There are other files there, and they don't have much in them, but let's see. So I created a file called defs, standing for definitions. And all this file has is a definition of board dim, okay? So this was a 3x3 tic-tac-toe, but if I would change board dim to 5 and run this again, you see I get a 5x5 tic-tac-toe. Okay, so this is a static change. The program could have also asked me, hey, what board dimension do you want? But some more provisions are needed for that. With your chess game, you don't need to go beyond 8x8. Chess has been 8x8 as long as humanity has played chess. I actually don't know this, so I'm not an expert of the history of chess. Maybe somebody knows it might be, or maybe you could read about it. Chess might have not been always 8x8. But this tic-tac-toe is kind of modular. So in no place do we have board dim hard-coded at 3. It's a variable, a global variable. So that's in the defs file. And there's also a file called printing, which in this case just has one function which prints a board. Now, in your chess game, you might use other files. You might have multiple helper files, and you kind of create those files based on context, and you put different functionality in these files. But the thing is, they are included into the main file, into the tic-tac-toe. So at line 9 here, we have from defs import everything, and from printing import everything. So this file tic-tac-toe.py is the main file that's run, and this is also where main happens. Okay. Let's now actually look at the main code. So, and I'll just overview this code very quickly. So we print tic-tac-toe, and then we have to make all kinds of decisions between ourselves, between, in this case, it was just me, between the programmer and himself, but maybe it's you and your programming friends, etc. Or it might be the person that would extend this code later on. So how do I encode whose turn it is? I could have used a Boolean, true or false. I could have used an integer because it's a two-player game, 1 or 2 or 0 or 1. I just decided to use the actual string X, okay? Then I have the main data structure of this game, which is the state of the game, just like when you look at a physical game. In this case, we call it board. And board gets a result from a function called init board. So the nice thing about functions, we won't look at init board just now, but you can kind of guess what init board does. It creates an empty board. Okay, so if I run this again now with a 3x3, right? The empty board is an empty board of 3x3. Now this is a game loop. Now, often you'd have while until a condition, but I actually prefer to use break statements. So then I do while true, and at some point, if we need to stop looping, we'll stop. And of course, we'll always stop. So what do? We just print a new line. We then display the board, print board, that does this thing. Okay, so that's in printing. We then say it's a turn of player turn. So player turn can be either X or O. We then get input, okay? Read the row, read the column, right? Convert the string to an integer. Players don't think of indices from 0 to 2. They think of indices from 1 to 3. So, but the program, because it's Python and it's zero-based indexing, goes from 0 to 2. So then we subtract the row, we decrement the row in the column. And then we see if this is not empty, okay, then we just print the spot as taken and try again. Okay. We check for victory. We shouldn't even have to check for victory there, but that's no big deal. Else, what we do is we actually populate that point with the player turn, with X or O. And this is where, for example, we don't do checking if the input was out of bounds or something like that. And then we switch. We say if the player turn with X, it's going to become O. Otherwise, it must have been O. That's at least our assumption, unless there's some bug and it's something else, and it's going to be X. Okay, so we switch turn, right? But if it wasn't this, then we won't switch turn. That's if the spot was taken. Then we're going to check for victory. So this variable victory is a return value of the check victory function, which is in a sense the most complex thing in this tic-tac-toe game, and that's not too complex, but it's the most complex. And we say if victory was the string stalemate. So again, here as the programmer, I've agreed between me and myself that stalemate would be the result of check victory of stalemate. So stalemate means that everything's populated and then nobody wins. I didn't show you such an example, but you can try it. Nobody wins, break, done. Else if the victory is either X or O, then just declare the victory and still break done. That's it. That's the game, right? So yeah, that's it. So basically a few things that were used here. One was init board. Let's start with that because that's simple. Init board, well, how do we define the board? The data structure that we use for the board here, if we would have used NumPy or something like that, and that's probably not what you're going to use, okay, for your chess game either, you could have had the board as a matrix. But here we're having the board as a list of lists. So we do a nested comprehension. So we run at an external list, and that's going to be the rows. And each row is a list in itself. So then in a sense, that's a way to represent a matrix. And we initialize it with these nothings, with an empty spot. Okay? Okay. The other important function is check victory. We'll get to that in a second. There's also a helper function is PC. That's a helper function for check victory. So it checks if a character is actually a piece. Okay, because maybe it's not a piece, maybe it's an underscore. The printing function just loops and prints the board, and that's it. So we're done with one function to look at, and that's this. We have one function to look at, and that's the function check victory. So check victory gets a board, and what is it going to do? It's going to return either an X or an O or a stalemate or a none if no victory is done. And it's quite repetitive the way it's coded, but everything here is slightly different. And, that's the quickest way I found to do it. Maybe there are more elegant solutions, but this seems to work. So first we check for the diagonal, meaning this diagonal. Okay, so we get the character at the top left corner. We say, if this thing is a piece, we're going to check something. If there's not a piece on the top left corner, like here, there's not a piece, we just don't have nothing to do. And we'll assume there's a victory first, and we'll work until we find there's no victory. And then we just run over the diagonal. And we go, if the board II, so this is an important construct. So this is the ith element of the list, which is a row. And that's a list in itself, and we take its ith element. So that's a diagonal. So if the diagonal is not what was there initially, then the win is false and we break. Okay, it doesn't mean we stop everything. We'll continue for the next thing, but we did a break out of this for loop. Okay, and if we actually had a win at the end, so if it didn't turn false, so that means if it's true in the end, then we return the piece at one. Checking for the anti-diagonal is the same way, except that we start at the top right corner. So that's the 0th row, its last element. And here we have to do some index arithmetic to go backwards, like that. Okay, so you could figure out how that works. Checking for the rows, well, we loop over the rows, and for each row I, we do the same type of thing. And checking for the columns, we loop over the columns. Now, if we haven't returned a victory up at this point, let's now do a check and see that if there is some empty spot, then we return a none. There's no victory. And if we got here to the end, that means that everything is populated with X's or O's, but there was no victory, so it's a stalemate. Of course, this type of function is kind of bug prone. There's a lot of assumptions here, etc. But I tested it for this, and after thinking about it logically, it works. Right? But if my program state would be obscured in one way or another due to some bug where I have some other character in the board, for example, that's neither an X or an O, then something can break, other things can break as well. Okay, so that's the game of tic-tac-toe. What I suggest that maybe you try to just make a small addition to this game, something, for example, just some sanity checking on the bounds, or maybe keep some score or something like that, just to see that you can play with it, and that will be warm up for your chess project. Hope you enjoy the process, and happy coding. Bye-bye.